All right, we're back. This unit is all about arrays, and I'd actually like to get some array practice in via CodingBat. I'm going to scroll down a little bit and find the Array-2 section. As you can see, these all require a loop. That's okay. We did a lot of common array algorithms that all ultimately needed a loop as well. So this is more practicing that. We'll be using for loops. We'll also be using for each loops in order to solve these things, and I'll talk about the differences as we encounter them. Let's get started. I'm going to go right into count evens. We wrote a count method. This is going to be very similar. It says return the number of even ints in the given array. Note that we can use mod, right? We can mod by 2 in order to determine if a number is even. For instance, 5 mod 2 is going to give me 1, indicating it is not even. Okay, so they give us some examples. This ultimately, given this array, gives us a value of 3 back out because we have a 2, and a 4. This one gives us a value of 3. Keep in mind that 0 is an even number. That is a factoid. Here, 0. Right? All of these are ultimately odd numbers. So I'm going to start out with an integer to keep track of my even number. So you could do count, where we're going to count the number of evens. You could say something like evens, I think is also a pretty good variable name. Right? This is the number of even numbers in the integer array. So we have an integer array called nums coming in, and ultimately we're returning an integer that is the number of evens. I'm ready to start looping. I'm going to plug in a for loop starting out, and this is what I would call the basic or normal for loop. I'm starting at index 0, and we'll keep going as long as I is less than length. We're starting at the beginning, going towards the end via an I++. With each iteration, I'm going to ask, is the current element, okay, the current element is going to be nums at I. I want to know, is that even? Okay, nums is an integer array. Nums at I is a single integer. So this is the integer I want to know. This is the current element that I want to know, is that thing even? Well, it's an integer. I can just perform any math operation on it, including mod. I'm going to mod by 2. And if the result happens to be a 0, what that tells me is that this element, the current element, is an even integer. If that's true, we'll increase evens by 1. We'll count it. We'll say that we found an even number. We'll increment it. If this is false, then we don't enter the body. Nothing happens. You'll notice that I've omitted braces here. There's only one statement in our for loop, an if statement. There's only one statement in our if statement. This evens plus plus. After the loop is over, I've gone through the entire array. I've checked every integer. I'm going to return whatever the current value of evens is. And you see we get every one of them correct. So this is a for loop approach. Now, ultimately, I don't really need the index because all we're working with here is the current element. What that means is I could use a for each loop in order to solve that. Okay. I'm still going to have to start out with this variable to keep track of my evens. I'm ultimately still going to return it. I'm just going to change how I'm looping through. Instead of a for loop, I'm going to use a for each loop. We're going to use the same reserved word. What we're looping through is nums. It is an integer array. Each individual element is a single integer. So because I'm looping through that, I will say for each int, which we will call whatever you want to call. In our video where we first learned about for each loops, I recommended using maybe E. X isn't terrible. It's not great. I find X to be like a specific number, like if you're searching for a specific number, for instance. So E standing for element, I think makes a lot of sense. When I first encountered for each loops and I had no idea what they were, I would see stuff like this. It would say for int E in A. And I basically had to teach myself that this meant element and this meant array. For instance, if this thing was called A, you could do this. But since we're calling it nums, which by the way, I think we can technically rename it here, we're going to loop through nums. Each individual element is an integer. So the way I would translate this in English, for each integer, which we will call E in nums, do something. What this syntax does is it makes it very clean. This is a lot more concise than what I previously had, our typical for loop. It naturally avoids index out of bounds errors. It is clean to any programmer that knows what it is because we know it's going from the beginning to the end. Keep in mind, an ultimate kind of downside to a for each loop is I can't kind of change the way it iterates. It always starts at the beginning. It's going to go through every element towards the end. But that's a positive as a programmer whenever you're reading someone else's code because you come across it and there's no trickery here. Beginning to end. Visit every element. Done. Okay. What it does is replace this syntax here, right? This is how we were previously getting the current element, by going into the array and accessing it. Instead, that gets handled behind the scenes, right? The first thing that actually happens behind the scenes, we don't see it, but integer e gets created and we're going to store the current element. So for the rest of the iteration, instead of saying nums at I, the current element is simply e. Okay, so I'm going to loop through using a for each loop. With each iteration, I'm going to ask, is the current element even? If it is, I increment evens. We're going to do that for the entire array. Whatever the final value of evens is, I'm going to return it. And there we have it. Note that even starts out at 0. And if this is just never true, right? If I never have an even element, it's still 0 whenever we get down here, which is how we get a correct solution for those. Let's look at the next one. Big diff. Given an array length 1 or more of ints, return the difference between the largest and smallest values in the array. Note the built-in math.min and math.max return the smaller or larger of two values. We'll look at different solutions, ones involving both of these methods, ones that we don't really need them because this is a simple if statement check. But this is basically min and max combined. We did our common array algorithms where we wrote a max method. In theory, you could write a minimum method that is almost identical. I'm going to make one pass over the array, okay? One thing that students typically do is they'll create a loop that goes through and finds the maximum. And they'll create a loop and they'll go through and find the minimum. But realities are, I could find the min and the max with just one loop, right? Just make one pass over the array, checking to see, is the current element greater than my previous max? Okay, we'll update max. Is the current element less than my previous min? Okay, we'll update our previous min. So I'm going to, because I know these things are integers, I'm going to create an integer to store my maximum. I'm going to create an integer to store my minimum. And if you're jumping out of your seat at what I'm doing right here, you should be. We'll come back to that in just a moment. Okay, I actually don't think, they don't say they're all positive values, but they may not even test it. So anyway, I'm going to loop through. I'll start out with the for loop. Here is our typical for loop from beginning to end. With each iteration, I want to know, is the current element greater than my previous maximum? If it is, I've found a new maximum. So I will say max is now the current element. And this gets updated as we go through the loop, right? With each iteration, I'm going to end up checking the current element to see if it's greater than my max. If it's not, my max doesn't change. So when our loop gets finished, whatever is in max should be the largest element in the entire array. Now, here's what's different from our common array algorithms. I'll do it as a separate if for now. We'll talk about why the else if is potentially better. While I'm here, I'm also going to check the current element against the minimum. If the current element happens to be less than my previous minimum, I found a new minimum, so I need to update it. I'll save the current element into my minimum. Same logic applies, right? I check every element. If the current element is not smaller than my previous minimum, then I don't update it. Whatever is in minimum, whenever my loop finishes, should be the smallest number in the entire array. Okay, so we're going to loop through, making one pass. If the current element is greater than my maximum, I'll update max. If the current element is smaller than my previous minimum, I'll update minimum. So whatever is stored in min and max should be the smallest elements. Ultimately, what we want to do is return the mathematical difference between the largest and smallest values of the array. Now, order, we're going to be doing subtraction, so order does matter here. Right? I'll create an integer diff, and then we'll end up taking this variable away. But I'm going to subtract my max minus my min. You could do some absolute value nonsense here, right? We could do math.abs on max minus min or min minus max. And in theory, that takes the order out of it, but that's not an issue here because we know which number is larger and which number is smaller, right? This is definitely the larger. This is definitely the smaller. So I will subtract that. I will find the difference, and the difference is ultimately what we need to return. So I'll do that. Okay, yikes. What happened here? What happened here, right? I'll zoom out a little bit. Here's my 4 elements, right? 10 should be the maximum. 3 should be the minimum. I should get a difference of 7. 10 minus 3. I got 10. And about the only way I can get 10 is if I did 10 minus 0. We encountered this problem whenever we were writing our max method. I don't want to start these values at 0. The reason being, in the case of max, what if I've got all negative numbers? In the case of minimum, what if everything is larger than 0? Okay, so these are like artificial min and maxes. If they never change, that's what's happening here. Wrong direction. My minimum starts out as 0. And I loop through and ask, are any of these numbers less than 0? No. So when I get to the end, I'm subtracting my max, which is 10. I'm finding that successfully. Minus 0, which is my min. I'm getting a 10, and that's what we're returning here for, like, all of them. Okay. So what I recommended in the Common Array Algorithms videos is to not start this at an arbitrary number, such as 0, and instead make it the first element in the array. Okay. I'm going to actually start both of them at this. So I'm going to assume that the first element is the maximum. I'm also going to assume it is the minimum. It is possible that that is true, period. Actually, if there's only one element in the array, that's technically a possibility. But they're likely going to change, right? I'm likely going to update these as we go. Note that they tell us that the array is a length 1 or more. So I actually am not going to have any index out of bounds issues. I actually don't need to check. There is a possibility, right, that the integer array has a length of 0, at which point this element doesn't exist and would give us an index out of bounds issue. But they tell us we're going to have a length 1 or more. Okay, let's try that. And that easy. Right? I am starting min at max not at 0, but at the first element. Okay. So a couple of improvements we can make, efficiency improvements. We're getting the right solution, right? So that's the main thing that matters. This variable down here, I'm doing some math and not really doing anything else with it, so there's no point in having the variable. We could just do the math at the point of return. I'm going to return the difference between max and min. Okay, you see we still get a correct solution. Another efficiency, I've already considered the first element. So on the very first iteration, whenever I is 0, I am ultimately comparing max to itself. I am comparing min to itself. That's a pointless iteration, right? It doesn't really do anything. It doesn't change anything. So I can actually start at index 1. You'll see that we get a correct solution, but it is more efficient, right? I shave off one iteration. It's not a lot in terms of processing power, but it's something. So it is technically more efficient. Another efficiency I would take here is with my if statements. I'm using 2 if statements, and again, it's obviously correct. We got a correct solution. But if this is true, if the current element is greater than my max, there is no way it is less than my minimum. Yet I still check this, right? It's two independent if statements. If this is true, I still check this. Okay, that is where I would bring in the else if. What this does is it makes it so we only check this if this is false. I'm only going to check to see if the current element is less than my minimum, if I've already proven it is not greater than my maximum. Okay. This technically makes this one statement, right? Because these, right, this part is intertwined with this, right? This is all one logic tree now. And because it is one statement, we can actually get rid of the braces here. Now, that starts to get a little bit funky. I don't know if I would recommend it in practice, but I wanted to show you that you can do it. Okay. We can do a for each loop here. The only problem being this iteration that we shaved off, you can't do that with the for each loop, right? The for each loop is going to start at the very beginning no matter what. So I wouldn't even consider the for each loop situation here because we are actually changing. This isn't a standard loop. We are technically skipping an iteration. Okay, this solution, maybe with the braces, is the one I would go with, what I would recommend. Super efficient. Let's take a look at the next one. Centered average. Return the centered average of an array of events, which we'll say is the mean average of the values, except ignoring the largest and smallest values in the array. If there are multiple copies of the smallest value, ignore just one copy, and likewise for the largest value. Use int division to produce the final average. You may assume that the array is length 3 or more. Okay, lots of things going on here. For one thing, we're going to have to get the average. But they want us to ignore the largest and smallest elements. So we're going to have to track those. This is going to feel very similar to what we just did. We're going to do a min and max thing where we track our smallest and largest elements. All we really have to do is track the max and min, track the sum. We'll subtract out max and min at the end after we're done looping before we actually find the average. Whenever we go to do our average, we need to do 2 less elements because we have subtracted out our max and min, but they make this sound a lot harder than what it actually is. Now, this part where it says use int division to produce the final average, we're ultimately returning an integer. We're working with integers because we are talking about dividing ultimately, right? That final step in order to find our average is division. It's integer division, so truncation can occur. What this is saying is that's okay. Whatever truncation occurs, let it fly. You may assume that the array is length 3 or more, so we are free to subtract out the 2 elements at the end, no matter what. Okay, I want to need some variables. I need a min. We just talked about how we want to start that as our first element. I need a max. First element. I'm going to need a sum. That can start at 0. Unless, if we are doing this, there is a high likelihood that I will just shave off the first iteration. So instead of starting sum at 0, which would mean if I were to shave off the first iteration in my loop, right? If we were to come in and say I starts at 1, I is less than nums.length, I plus plus, all right, I'm shaving off the first iteration because I'm not starting I at 0. If I still need to track my sum, however, and as it stands right now, I wouldn't get that element, not in the loop. So if we're going to take this approach that is efficient, we can start nums. We can start sum at nums at 0 as well. Right? I've already got the first element into my sum. So it's as if I already added it to sum. All right, let's loop through. With each iteration, I'm going to ask, is the current element, is nums at I greater than my max? And if it is, we update max. Else if, right, we just talked about why you want to do that, it is less than my minimum, I'm going to update my minimum. Regardless of what we do need to update sum. We need to add the current element to our sum. I'm going to say sum is what it was plus the current element. Okay. So some things I would consider here. I refer to nums that I here. And here, and here, and here, and here. A variable might make some sense. I'm still avoiding the for each loop because we are shaving off that first iteration, and I can't do that with the for each loop. But I'm going to kind of take a page out of the for each loop and save in the current element. Okay, why? Well, whenever you do this, this is taking some processing. It also gets a lot more symbols in it, right? We got a lot more characters here, if you will. So I can basically take this and save it into a variable, which will change the way that I can refer to it for the rest of the iteration. Right? We are drastically reducing the amount of text that's on our screen by doing this. You can take it or leave it. Actually accessing the element may be an identical process to just accessing a variable. So I actually don't know if we get any efficiency here. But at the very end, this could be a shorthand assignment operator, right? So instead of saying sum is sum plus e, I'm just going to do a plus equals. Okay, so after our loop is over, whatever the maximum value is, it should be in max. Whatever the minimum value is, it should be in min. My sum should be everything. But they want us to ignore the largest and smallest values. That was the whole reason we even tracked our min and max. So what I want to do is subtract those out. I don't want them to be part of my sum. I'm going to update sum. It is going to be what it was minus max plus min. Right, I'm going to subtract both of these things out of my sum. This could be rewritten, I think, only because I got the parentheses there. The last thing I need to do, I have a sum, I have a total. What I need to do is take the average. Okay, well, how many elements? How many elements did we actually process? Ultimately, we went through the entire array, right? The number of elements that are in our calculation is equal to the length minus max minus min. So it is the length of the array, the total number of integers in the array minus 2. So whenever I go to take this final average, whenever I go to do the average, I'm going to do the sum divided by the length minus 2. Hopefully you got some alarm bells going off. What has highest precedence here? Right? It's going to be the division, which means I'm actually going to do that first. Like up here, we need to make sure we do the correct thing first. I'm going to put parentheses around that. Right? Nums.length is all of the numbers. Right? Is the length of the array. The length in this example is 5. The length in this example is 7. But because I'm ignoring max and min, I just subtract off 2. Okay, let's try this. That's a yikes. I actually thought this was going to work. What happened here? Expected 3. I gave them 36. That doesn't sound like my min and max is coming out correctly. Oh, if the current element is greater than max. How did I make that mistake? Bruh. Okay. This is ultimately the solution I would recommend. You could do some trickery with this here at the point of return that starts getting messy and affecting readability. I don't think this is too terrible because all we're doing is taking the average. I would maybe include a comment here. But using a for loop, shaving off that first iteration, starting sum at the first element, I recommend basically all of these things. we're able to clean up a lot of the stuff here. I don't know if I would personally do that in practice, but I did want to show it as an option. Let's do one more. Sum 1, 3. Return the sum of the numbers in the array, returning 0 for an empty array. So it is possible that there's nothing in the array. Except the number 13 is very unlucky, so it does not count. And the numbers that come immediately after a 13 also do not count. Okay, this is the first time that we're going to look at an element as well as the one immediately after it. I can go ahead and tell you what we're going to be looking at is the current element, nums at I, as well as the one next to it, which is nums at I plus 1. Because of that I plus 1, this is not a for each loop problem. We're going to use a normal for loop, and I care about the index. I need the index in order to know what is adjacent to the current element. So I'm going to create a sum variable, and we can start it at 0. Okay, I'm ready to start looping, and as I just said, we're going to need a for loop, a traditional for loop, a basic boy here. Let's take a look at maybe some of the examples. So here, we end up just getting the sum, right? 1, 2, 2, and 1. Add it all up together is a 6. 1 and 1, that adds up to 2. These aren't very good examples. All of these numbers, in theory, should be, what, 19? But this is saying that the number 13 is unlucky, so we're not going to count it towards our total. I hate the fact that they didn't include a example that involves the 13 after the fact. So, oh, come on. I was hoping I could hit go, see some test cases. We can get there. It's okay. So I'm going to start out with my sum. It's nothing. I'm going to loop through. I'm going to begin with a normie loop. We're going to end up changing it a little bit, I promise. With each iteration, I'm going to ask, is the current number of 13? Because if it is, I don't want to add it. Right? A better way to think about that, right? Because if I said nums at I is equal to a 13, well, that's actually an iteration where I don't want to do anything, right? We would basically be saying sum doesn't change. What I want to do is add to my sum if it's not a 13. That is a more meaningful statement, right? If the current element is not a 13, I'm going to add it to my sum. Boom. Right? After the loop is over, I've counted everything but 13, so I'm going to return my sum. I know this is not going to be a correct solution. Right? We did get a lot of things right, except, take a look at this one. I'm supposed to get 4. On run, I gave it 6. I ignored... Okay, the number's after 13. All right, I got you. All right, so how do they get 4? Well, they're adding 1 and 2. That's 3 so far. They're ignoring the 13. Okay. What they are also doing is ignoring the numbers that come immediately after the 13, which means this 2 also did not get included. They ultimately add this 1. So the numbers that get added are the 1, 2, and the 1, and that's how they got a 4. Right now, my implementation is, it's ignoring the 13s, but that's it. So this 2 snuck in to my summation. Okay? I'm going to show you something big brain. I'm not even going to play around here. I guess that's an else. If the current number is not a 13, I'm going to add it to my sum. If I hit this else, what it means is the current number is a 13. I'm not going to add anything to my sum, but what I am going to do in order to skip the next element is increase my index by 1. We don't normally see this kind of thing, right? I have something pertaining to my counter variable inside the body of my for loop, but that is actually going to cause me to skip the element after. Let's pull this test case and see how it works. I should put it at the top. Okay, so whenever we first start out, we create sum. It has a value of 0. We are going to create I here, right? I gets created. It has a value of 0, which puts it right there in terms of our array. Okay, we're going to ask, is I less than our length? Yeah. We'd enter the body. We'd ask, is the current element, a 1, not equal to 13? That's true. I'm going to add it to my sum. The new value for sum is 1. We would skip the else because we executed the if. I come up here, do an I++. We're now here. We'll ask, is I less than our length? Yes. Is the current element not equal to a 13? It's true. I'm going to add it to my sum. Sum is now a 3. Because we executed the if, we would skip the else. We'd come up here, do an I++. We're now here. We'll ask, is I less than our length? Yep, we're still in bounds. Is the current element, a 13, not equal to 13? That is false. 13 is equal to 13, so this is false. We'll skip this body. We will execute the else, which simply says I++. That puts me here. Uh-oh. Except I'm still going to come up here and do I++. That's how we skip that too. I would ask, am I still in bounds? Yep. Is the current element not a 13? That's true. We'll add it to our sum. We get a 4. We skip the else. We do an I++. We're here. We would ask, are we still in bounds? Yes. Is the current element not a 13? That is false. I would do an I++, which puts us here. I would still technically do this I++, which puts us even further out. We would ask, are we in bounds? No. So that's how that little trickeration works. At this point, this is technically associated. It is one statement. You can get rid of these braces. I don't really recommend it. Right, I would likely say that the version with these braces is more programmers are going to understand this than what was previously there, right? This kind of just looks like this has no association with the other stuff, and it does. So I recommend the braces. And I'm going to recommend this as a solution. That's it for now. I'll see you in the next one.